All right, so in this video, we're going to pick up with our discussion of a direct and split injector, and the other two injectors that are out there for me as options. So previously we talked about direct vaporization, and we said this is basically squirting the sample into the machine. It automatically changes into a gas on me, and it goes into the column. But we said that it really is only used for a packed column, and that's it. This tube can have a glass sleeve, but do not let that confuse you with a glass insert. They're not really the same at all. Okay, a glass insert is different than this glass sleeve that it's referring to in the slide. This is just an encasing that surrounds the internals of the machine that allows my sample to go into before it goes directly into the column. All right, and then we also talked about the split injector, and we said the split injector basically takes a sample, and that sample is maybe still way too concentrated to put onto my machine, even at 1 microliter. And the split will allow me to take that 1 microliter and divide it up even smaller. And we only inject a very small portion of that sample into the GC. And we said this is good because this is the most common type of injector that's out there. But sometimes split is bad. And this is when the sample that I'm trying to use is very, very low in concentration. And I need to inject quite a bit of that sample in order for my machine to pick up that detection limit. Okay, so now we need to talk about the next two different types of GC injectors. Okay, so there's two more. So up here at the top, GC injectors, and this is going to be a number 3. Now, number 2 was called a split injector. Number 3 is called a splitless injector. And you kind of probably saw this coming, right? A splitless injector is made just like a split. Okay, so it's made like the split detector or the split injector. However, it does not divide my sample in smaller portions. It injects all. All right, so this is how I need you to imagine this type of detector or this type of injector. Here we have the injector port up at the very top, and we've got a syringe that goes down into that injector port that's filled with my sample. And I've got a piece of rubber septum that sits below. And I have squirted some sample into my machine. So here is my sample that's now in a gas, and that needs to go into the column. Okay, so what happens is that in a split injector, some of my sample leaves and goes out of the side, and only a small portion of that goes into the column itself. However, sometimes my sample is so weak that I don't want that to happen. And what I can do is I can go into the instrument and I can tell the instrument to cut this off. Don't use it. And all of my sample at that point, all of these components go into the column from that point on because I have closed that window out. This is very similar to a direct injection. The difference is that here at the very end, this column is a capillary column. In the direct injector, it was a packed column, a little bit bigger, a little bit wider, so that direct injector is made slightly different. The good news is that when I order a GC, for the most part, the GC will come with a splitless detector. I keep saying it, detector. It's injector. I'm going to have to slap myself every time I do that. And this gives me some flexibility. Most of the time, I will run a split injector, and that will inject my sample into the machine. But every now and then I might get a sample that's really, really weak. And what I can do is I can go into the software and I can cut my split off and tell the machine to go to splitless instead. And it's the same injector up here at the very top. There's no difference in it. The only thing that it does is that it closes this valve off and it prevents the sample from leaving. So that forces all of the sample now into the capillary column. Now, the split and splitless both do take the rubber septum and they both do take the glass insert. Okay? Again, there's no difference in those injector ports at all. The only thing that happens in a splitless is that this valve over to the side is cut off, so it will inject all of your sample that you've put into the machine. All right, finally, our last type of injector is called an on column. So we have direct, we have split, we have splitless, and then we have on column. Now, the thing with the on column injection, this is how it's a little bit different than all the others. It is performed cold. You don't really heat the injector up first. This is like putting a cake in your oven without turning the oven on first. You put it in cold, and then you turn the oven on and allow it to warm up while the cake is on the inside. The same thing happens here. You inject your sample into the machine. That sample goes into a very cold injector port, and the injector port will then begin to heat up. And then when it begins to heat up, your sample will go to a gas very slowly, and it will trickle into the column from that point on. It is heated. It still goes to a gas. It still can get hot. And what you want is about 100% of your sample to get injected onto the machine. So really, it's kind of like splitless. You want everything to be measured. The difference, though, is that this starts off as cold. The good thing, and why you would use it, is that these are very good for low boiling point volatile organic compounds. These are things that evaporate off at a really, really low temperature. A lot of times, if you put those into a hot injector port, all of these low boiling points will come off at one time and you'll just get a big old blob on your chromatogram. And that's not what you want. So if you do this cold, you allow these really low boiling points to get a head start. And then you might see one of these components come off and come back. And then another component to come off and come back. And another one to come off and come back. So it allows them to separate a little bit better in your chromatogram because of that. And it gives you more control and more flexibility. Not only that, but we call it on column because it traditionally goes directly on the column. We often talk about these glass inserts and all of these pieces and parts that might sit up underneath the septum, but this one, in this case, is injected cold and it goes directly on the column itself, and then this way it will slowly heat up and slowly come off of the machine one at a time. All right, so now we need to take a proper look at a injector port itself. All right, and this is what the types of injectors will look like as far as diagrams go. So the very first one is direct injection, and this was the first one that we talked about as well. And we see the carrier gas helium coming into the injector. Here is that dial up here at the top, and there's my rubber septum. And my helium comes in, and here is my sample. And my helium mixes with the sample that's heated, and then it goes into the column eventually. Now, the thing here with direct injection is that this is traditionally a packed column, not a capillary column. Over next is my split injection. The split injection is made for capillary columns. So this is the big change for it. Carrier gas still comes in. It mixes with the sample. And I see a lot of my sample leave the injector port. And a very tiny fraction gets injected onto the capillary column. The next one is my splitless injection. The same setup. Notice there's no difference in these two injector port drawings. My helium comes in, mixes with the sample, but in splitless, this valve is closed. So all of it goes onto the capillary column. So once again, this is for capillary columns, and that's why this is not called a direct injection technique, because this is really for packed. And then finally, here's my on-column injection. So there's my injector, and that sample gets basically directly injected onto the column, and this is slowly heated up little bit by little bit, and it allows those very low boiling point volatile organic compounds to come off one at a time. So on a test, what you might expect is maybe a drawing of one of these, and it will say, which one is it? Is it on column? Is it splitless? Is it split? Is it direct? Which one do you have at this moment in time? You'll also see another diagram that's a little bit closer up, maybe some more detail. And here you really do see the different pieces and parts. So up here at the top is the round injector port, and your needle will come in from this side, and it will be inserted into the injector itself. This piece of rubber septum, that's what we've always talked about. There's my helium entrance that begins to mix with my sample. This blue bar to the left and to the right, that's supposed to represent the actual glass insert. So really, there's a bar to the left and right, but this is the actual tube that sits down inside of the injector port itself. And then this thing is heated, right? This metal block, that's how you heat your injector ports. So your sample mixes with the helium, and then a small portion of that goes into the column itself, which sits down here below. All right, so that's the pictures of the different types of injectors that you will see on a GC system. Those are the different pieces and parts that's major that we have with a GC system. And in the next video, we're going to talk about a new topic now. And that new topic is going to be columns. So we've venturing out of the carrier gas. We've ventured now out of the injector ports. And now we need to discuss the types of columns that would be on a GC system.